This lesson is going to be on hurricanes. Hurricanes happen to be the most violent storms on Earth. To be a hurricane, you must have some certain characteristics. Wind speeds must be in excess of 75 miles per hour, and there must be some rotary cyclonic circulation taking place. Hurricanes originate typically right around the equatorial, just about 5 to 20 degrees latitude, either north or south. It is important to realize that hurricanes are synonymous or the same thing as typhoons and cyclones. It just depends on where they are geographically located that'll determine their name. Notice hurricanes take place in the Atlantic. That's what we've come to know and call hurricanes. Typhoons take place in the Western Pacific, and cyclones take place in the Indian Ocean. So we've got a couple different scenarios playing out, and it's important that just the naming system, cyclones, typhoons, and hurricanes, are all synonymous to one another. So why do they rotate counterclockwise and move from the east to west? Well, there's two parts here. The first one, counterclockwise, is a result of Coriolis. As air moves inward, it gets deflected to the right, and this creates the counterclockwise rotation. It's common or characteristic of low pressure systems, just like a mid-latitude cyclone would along in our area as it travels through weather pattern. But why does it move from east to west? Well, trade winds are the prevailing winds, so they blow them to the west, from the east to the west. So the prevailing winds are driving the wind pattern, so it's pushing the entire air mass toward the west. In this case, we've got internal pressure going on, we've got a rotation, we get these very distinctive rain bands, we got an eye directly in the center. It's actually very calm inside the eye. Then we get these very, very distinguishable eye wall itself. The profile, when we talk about the eye, this is the very center. It's about 12.5 roughly miles in diameter. Precipitation ceases, wind subsides, air gradually descends and heats by compression, and this is typically the warmest part of the storm itself. Here we have a picture that I like this picture because it's identifying there's a lot of factors and features taking place. But a hurricane, what does it need? What does it really need? Well, it needs warm ocean water, and it gets to a certain temperature of greater than 80 degrees Fahrenheit, and this provides the energy that causes more evaporation, making humid air and clouds. So you get this warm fuel, and it just allows for adiabatics, right? Convection takes place, it heats the air above it, the air rises, you get moisture, you get heat, you have the ingredients for trouble. Here we get parts of the hurricane itself. When we talk about the eye wall, this is the near the center of the hurricane itself. This is where air is rising, intense convection taking place. It's moving vertically, it's rotating, there's a whole lot going on here. Low pressure around the eye. Notice it's actually high pressure in the center. This is where air is descending. That's the reason why it's a very distinguishable air open spot, or you can see the eye. Air is actually descending in the middle, just like a high pressure system would. But low pressure around it, generating clouds and winds and heavy rainfall, etc. And the rain bands are the clouds that are surrounding it. These are the very distinctive bands are on the outside, and you normally can get between 5 and 15 rain bands, and very, very powerful amounts of rain coming and going. Notice that pressure is related to the number, or the powerful, let's just say the power of the hurricane itself, right? The lower the pressure, right, the greater the amount of size or speed that's taking place within the hurricane itself. So it really shows that low pressure systems are going to lead to really, really powerful storms themselves. So notice that there's a relationship here. They're inversely related, that the lower the pressure, the greater the wind speed here. So that's kind of what this graph is trying to indicate. Moving on, hurricanes form, right? Energy comes from condensing water vapor. They develop in late summer when warm water temperatures provide energy and moisture, right? We could follow an isotherm map where the late summer, remember our seasonal thermal lag time, later in the summer, we get more heat energy, we get insolation at its past its prime, past its maximum, but you get the warmest temperature because of that lag. Tropical depression, this takes place after the initial stage. The initial stage is just kind of a developing storm, and then it amplifies itself as it continues to move over warm water. So here we have 38 miles per hour kind of defines a tropical depression. We get into a tropical storm where it increases its wind speed from 38 to 74 miles per hour before it then becomes an all-out hurricane. Wind speeds can reach up to 300 kilometers per hour, right, roughly 200 miles per hour, and they can generate up to 50-foot waves at sea. These form in all tropical waters except for the South Atlantic and the eastern South Pacific. Here we have the death of a hurricane, if you will. They diminish in intensity, right? In their life cycle, they're born, they kind of reach this maturation, but then they die out. When they move over cooler ocean water where they no longer have the fuel to drive them rising vertically, or they move onto land, or the large-scale flow aloft is unfavorable. Literally, upper-level winds can destroy a hurricane cloud, a mature hurricane in no time. Now you'll want to go back and read these, but I want you just to see here. This is a nice little picture that identifies you've got outflow. This is feeding the rain bands around the eye of the hurricane, and here we have a very distinguishable eye wall. Here we have air rising in different locations. So there's all kinds of inner workings going on within the hurricane itself. And then we get these really powerful rain bands, and we're talking tremendous amounts of rains. So you can actually have, if you're located here, or at a location, we'll just call it X right here on this margin. And this hurricane, let's say we're traveling to the right for the sake of conversation. You would get rain, then it would pause for a little bit, then rain and winds, then it would pause, then rain and winds and pause, rain and winds, pause. And you really just get these changing conditions that are all of which are extreme. It's measured in the Saffir-Simpson scale. I think that's an important one to identify, that the Saffir-Simpson scale defines a hurricane based on wind speed. I don't care if we can call it knots. In this case, we'll identify it as miles per hour, and pressure. You know, the air pressure. The lower the pressure is associated with the more intensity of the winds themselves. When we talk about the destruction from a hurricane, more often than not, it's the storm surge that does damage. You know, it's water. Water becomes even though as much as we would like to think we need it tremendously to live, it actually can be very, very dangerous when we get large amounts of it. The storm surge is a large dome of water, 65 to 80 kilometers wide. It sweeps across the coast where the eye makes landfall. And this is where tremendous amounts of water literally get pushed onto shore. So the eye wall is just the location that is normally associated with the storm surge itself. This is from low pressure and the winds that are building up the wall, the dome of water, and that's typically the danger zone.